Hi guys, I welcome you to another episode of Learning Physics with IBM, and I am taking you into force, density and pressure, and I think this is going to be part 4. So without wasting time, I would like to take you to part 4 of solved past paper questions, that is force, density and pressure. So I think in part 3 we stopped on page 23. I think in part 3 we stopped on page 23, and in part 4 I want us to start from page 23. Page 24. So without wasting time, let's start part 4 of force, density and pressure. A cylinder contains a volume of 0.012 meters cubed, a gas at a pressure of 1.0 times 10 power 5 pascals. 400 joules of work is done on this gas with its pressure remaining constant throughout. What is the final volume of the gas? Of course, this is a simple question. Pressure due to a gas. Work done due to a gas. Work done is equal to pressure times change in volume. So the work done is 400 joules. So I'll just simply say 400 joules is equal to the pressure is 1.0 times 10 power 5 pascals, and change in volume. The volume changes from the work is done on the gas. That means the gas is compressed. So the initial volume is greater than the final volume. So I'll just simply say 0.012 minus the final volume V. So just pressing my calculator, this will be 400 divided by open brackets 1 exponent 5. So that is the change in volume is going to be that. So this will be, I want V, so V is going to be equal to 0.012 minus the answer. So this is 8 times 10 power 3. So this is 8 times 10 power minus 3 meters cubed. So this is the same as, I think, 0.008. So the answer is going to be B. A cylindrical iceberg of height h floats in seawater. The top of the iceberg is at a height h above the surface of the water. The density of ice is rho I, and the density of seawater is rho W. What is the height h of the iceberg above the seawater? So remember, the weight of the water displaced is going to be equal to the weight of the iceberg, which is submerged. So that is very important. So I'll say weight of the water, which is displaced, is going to be the weight of the iceberg, which is submerged. That is in accordance with Archimedes' principle. So the weight of water is going to be mass of the water times G. This should be equal to the weight of the iceberg submerged, which is mass of the iceberg, then times G. So we remain with only the mass. So it means the mass is density times volume. So the density of the iceberg times the volume of the iceberg should be the same as the density of water multiplied by the volume of water. And remember, volume is cross-sectional area times another height. So for iceberg, this will be density of iceberg times the cross-sectional area, which is A, cross-sectional area of the cylinder, let's call it A, times the height of this iceberg cylinder, which is H, should be equal to the density of water. The volume of water is going to be the same cross-sectional area because the same cross-sectional area is displacing the water, but the height which is displaced is going to be H minus small h. That is, the height of water displaced is going to be the height due to this part only. So that is going to be H minus small h. So when I make the question is, what is the height h, small h, of the iceberg above the seawater? So I want small h. So cross-sectional area cancels out, and if cross-sectional area cancels out, it means if I open the bracket or I collect like terms, it means that the density of the iceberg times capital H is going to be, okay, let me open the bracket, is going to be equal to the density of water times capital H minus the density of water times small h. So I want to make small h the subject. Making small h the subject, it means I will have density of water minus density of iceberg into brackets capital H divided by the density of the water. When I make small h the subject, as a mathematician, you should be able to do that. So if you try to divide through mathematically, so h is going to be rho w divided by rho w, that is 1 minus density of the iceberg over density of water, then this is times h. So it means our answer is going to be A. So by Archimedes' principle, we say the weight of water displaced should be the same as the weight of the iceberg. That is in accordance to Archimedes' principle. So that's what I've used here. Okay, the couple is applied to a tap as shown in the figure here. What is the torque of the couple? Of course, the torque of the couple is the product of one of the forces times the perpendicular distance between the two forces, and that will be D plus D, which is twice D. So this means our answer is going to be F, or twice F times D. So the answer is going to be C. A crane uses a counterweight to stop it from toppling over when lifting a load as shown here. Okay. The counterweight has a mass of 500 grams, 5,000 grams, kilograms. The crane is required to lift the load of 12.0 kilonewtons, and the horizontal distance from the pivot of the load is 17 meters. So the horizontal distance is 17 meters. How far from the pivot should the center of gravity of the counterweight be positioned in order to keep the crane in equilibrium? So how far from the center? So I'll call this one simply x. And taking moments above the pivot, then it means 5,000 times 9.81, that is the force due to that weight, times its perpendicular distance x should be equal to, this is of course going to cause a anti-clockwise moment when this causes clockwise moment. So this is going to be 12,000 times the perpendicular distance, which is 17. So without wasting time, I'll just press my calculator. 12,000 times 17 I'll divide by 5,000 times 9.81. So this is giving me 4.16 or 4.159. So x is 4.16 meters. So let's see the answers. How far from the pivot should the center of gravity of the counterweight be positioned in order to keep the crane in equilibrium? So the answer is C, 4.16 meters. Three power forces act on an object. As a result of these forces, the object is in equilibrium. What must be correct for these forces? Of course, for three forces acting on a body in equilibrium, they form a closed triangle, and when you prolong them, they should be meeting at the same point. So they all act along the same line. That will not cause equilibrium. They have the same magnitude. That may not cause equilibrium. They do not act along the same line. What must be correct for these forces? They do not all act along the same line. They do not all act along the same line. They do not all have the same magnitude. So the most appropriate, I think, is going to be D. If there are three forces, there are three parallel forces acting on an object. Three parallel forces acting on an object, then they should not have they should not all have the same magnitude if they are to form a resultant which is 0. Because if they all have the same magnitude and they're acting parallel, then there's a possibility that there's a resultant force in one direction. So the answer is going to be D. An empty glass beaker has a mass of 103 grams. When filled with water, it has a total mass of 361 grams. When filled with cooking oil, it has a total mass of when filled with cooking oil, it has a total mass of 351 grams. An empty glass beaker has a mass of 103 grams. That is empty. When filled with water, it has a mass of 361 grams. That is for water. When filled with cooking oil, it has a mass of 351 grams. The density of water is, of course, 1 gram per centimeter cubed. What is the density of cooking oil? So, the mass of water can easily be obtained from 361 minus 103. I think without pressing the calculator, this is 258 grams. Then the mass of oil should be, you have 351 minus the empty, so 351 minus 103. And I think without pressing the calculator, this is 248 grams. So the question is, what is the density of the cooking oil? So density of oil, the density of oil is going to be equal to the mass of oil, which is 248 divided by the volume of oil. And also the density of water, which is equal to 1 gram, is equal to the mass of water, which is 258. Because they are all filling the same container, it means the volume is the same. So this is divided by the volume V. So it means where there is V, I will just put there 285 centimeters cubed. So it means the density of oil is simply going to be 248 divided by V. From this expression here, V is going to be equal to 258. So divided by 258. So I'll just press my calculator. 248 divided by 258. So my answer is 0.961. So density is 0.961. So the answer is A. A submarine descends vertically at constant velocity. The three forces acting on the submarine are viscous drag, upthrust, and weight. Which relationship between their magnitudes is correct? Which relationship between their magnitudes is correct? A submarine descends vertically at constant velocity. At constant velocity. That means the drag force is constant. Three forces acting on the submarine are viscous drag, upthrust, and weight. So let's think of this as a submarine. The weight is vertically downwards. Because it's descending vertically downwards, of course the upthrust is upwards, and the drag force is also upwards. So since it is descending at a constant speed, then it means that the weight should be equal to the upthrust plus the drag force. The weight is constant, the upthrust is constant, the drag force is constant. So the question is, which relationship between their magnitudes is correct? So you see that for weight, we get the upthrust plus the drag force. So it means the weight is greater than the upthrust. So this one is wrong, this one is wrong. The weight is less than the drag, that is wrong. The weight is greater than the upthrust, so the answer is D. Because weight is upthrust plus the drag force. So the weight is greater than the upthrust, it is also greater than the drag force. Because you sum the upthrust and the drag force to get the weight. So the answer is D. A car of mass m travels at constant speed up a slope at an angle theta to the horizontal as shown in the diagram. Air resistance and friction provide a resistive force F. The acceleration of free fall is G. What is the force needed to propel the car at the constant speed? So if it is to move upwards at a constant speed, the resultant force upwards should be equal to the force downwards. But what is the force downwards? It is going to be the resistive force plus the component of the weight parallel to the plane. So when we resolve the weight parallel to the plane, let the weight be mg. Parallel to the plane, this is mg sine theta. Of course, perpendicular, it will be mg cos. So it means the force downwards is going to be F plus mg sine theta. This should be equal to the force upwards, so that the resultant is 0, so that there is no acceleration, so that the speed remains constant. For constant speed, acceleration is 0, resultant force is equal to, force resultant is going to be 0. So the force up the plane should be equal to the force down the plane, and the force down the plane is F plus mg sine theta. So this is going to be D. A volume of 1.5 meters cubed of water is mixed with 0.5 meters cubed of alcohol. The density of water is 1000 and the density of alcohol is 800. The volume of the mixture is 2 meters cubed. What is the density of the mixture? Okay, so we know that density of the mixture is equal to the total mass of the mixture. Density of the mixture is the total mass of the mixture divided by the total volume of the mixture. So mass is density times volume. So I'll just be multiplying total mass for alcohol. For water, it is going to be 1.5 times the volume, which is 1000, plus for alcohol, it is going to be 0.5 times the density, which is 800. That is total mass. Divide by total volume. Total volume is given by 2. So I just place my calculator. Open brackets, 1.5 times 1000 plus open another bracket, 0.5 times 800 divided by 2. So that is giving me 950. So this is 950 kilograms per meters cubed. So the answer is D. A picture is suspended from a nail by a single cord connected to 2 points X and Y. On the picture, there is negligible friction between the cord and the nail, so that the tension in both sides of the cord is the same. The picture hangs symmetrically. Okay, if it hangs symmetrically, then these angles are going to be equal. So this is going to be theta, this is going to be theta mathematically. The tension in the cord is T. So tension here is T. The angle between the cord and the vertical is theta on both sides. Which statement is correct? Let's first find what the tension for equilibrium. Let's say the weight of this is acting downwards, and that is W. What is the weight going to be equal to? There is tension here and tension here. When we combine them upwards, they should give us the weight. So resolving tension vertically upwards, this will be T cos theta, but this side it will also be T cos theta upwards. So when we sum them up, it will be twice T cos theta balancing with the weight downwards. So which statement is correct? Okay, increasing the length of the cord with the points X and Y in the same place on the picture would reduce the tension in the cord. Note that the tension is going to be equal to weight over 2 cos theta. And what happens to theta when we increase the length of the cord? Increasing the length of the cord with the points X and Y. Of course, if the length increases, the angle theta is going to become smaller. If we increase the length of these cords further, it means with X and Y remaining the same point, it means this becomes smaller. And when theta decreases, it means cos of theta actually increases. When theta decreases, cos of theta increases. And if cos of theta increases, because 2 cos theta is in the denominator, it means t actually decreases. So increasing the length of the cord with the points X and Y in the same place on the picture would reduce the tension. So this is correct. The answer is going to be A. I'll not check the rest. You can go through the rest. A shop sign weighs 75 newtons from a frame attached to the vertical wall. The frame consists of a rod XY and a rod YZ that is at an angle of 30 degrees to the horizontal. Rod XY is attached to the wall by a hinge at X and has length 0.5 meters. Assume that the weights of the rods are negligible. Assume that the weights of the rods are negligible. What is the horizontal force exerted by the wall on the rod XY? So we want the normal reaction from the wall, which I will call R. So I will resolve this. There is tension here, T. When I resolve T vertically upwards using the angle 30, this will be T sine of 30. And when I resolve T in the horizontal, it will point in this direction, and this will be T cos of 30. So for equilibrium in the horizontal, T cos 30 should be equal to R. Those are two unknowns. For equilibrium in the vertical, T sine of 30 times the perpendicular distance. T sine 30 times the perpendicular distance, which is 0.5, should be equal to times 0.5. That is the perpendicular distance from point X, should be equal to, of course, T sine 30 is causing anticlockwise moment about X, and the sine will cause clockwise moment. So this should be equal to 75 times 0.5. Of course, it's the same as saying T sine 30 is equal to 75. Okay. So when we combine these two equations, I'll just divide T sine of 30 divided by T cos of 30 is equal to 75 divided by R. So this is tan. Tan of 30 is equal to 75 over R. So what is R? R is going to be equal to 75 divided by tan of 30. So 75 divided by tan of 30. So this is 129.9, which is approximately 130. So this is R is going to be 130 newtons. So the answer is C. What is the torque of a couple? What is the torque of the couple? Torque. So of course, a couple refers to two equal but parallel forces. So let's check. It is the product of force. Torque is product of force times perpendicular distance. So want the torque of the couple, which is the product of one of the forces and the perpendicular distance between the two forces. So the torque is going to be one of the forces, which is 15, times the perpendicular distance between the two forces, which is 5 times 10 power negative 2 to change it to meters. So that is 15 times 5 exponent negative 2. So this is 0.75. Of course, I don't need to use this because a couple is a product of a moment of a couple is the product of one of the forces times the perpendicular distance between the two forces. So the answer is simply 0.75. So the answer is A. Water has density 1 gram. Glycerin has density 1.3 gram per centimeter cubed. A student measures out a volume of 40 centimeters cubed of glycerin into a container. The student adds water to the container to make a mixture of water and glycerin. Assume that the total volume of the water and glycerin does not change. So total volume of water and glycerin does not change when the two liquids are mixed. Which volume of water needs to be added to the mix to make a mixture of density 1.1 gram per centimeter cubed? Of course, this is an easy question. Number one to start with. We know that density is mass. Density of a mixture is going to be total mass of the mixture divided by total volume of the mixture. So let me say total mass, MT over total volume, V total. And the density has been given as 1.1 gram per centimeter cubed. This will be total mass. Remember, mass is density times volume. So this will be density of water times the volume of water plus density of glycerin times the volume of glycerin divided by total volume of water plus volume of glycerin, that is total volume. Okay, so let's now go and substitute. So we say 1.1 equals to density of water is 1 gram, volume of water is not known. So I will say 1 times volume of water, which is simply VW, plus density of glycerin is 1.3, volume of glycerin is 40. So I will say 1.3 times 40 divided by volume of water is not known. I'll quote VW plus volume of glycerin is 40. So just solve this equation. 1.1 times that, so I'll have 1.1 VW plus 44, I think. 1.1 times 40, that is 44, equals to volume of water plus 1.3 times 40, I think that is 52. So collecting like terms, I have 1.1 minus 1, which is 0.1 VW, should be equal to 52 minus 44, which is 8. Then we divide both sides, so VW, I think that is 80 centimeters cubed, so the answer is D. VW is going, when I divide 0.1, 8 by 0.1, I think that is 80, so the answer is D. A wooden block rests on the rough surface of a board. One end of the board is then raised until the block slides down the board at constant velocity. So it is at constant velocity, acceleration is 0, resultant force should be 0 along the plane. What describes the forces? What describes the forces acting on the block when it is sliding with constant velocity? Sliding with constant velocity, the resultant force must be 0. So this one and this one should be out. Then, but of course they said, what describes the forces acting on the block when it is sliding with a constant velocity? Of course, since it is sliding downwards, friction must be in the opposite direction. So it means B is out, since it is showing friction is downwards, yet it is sliding downwards. So the answer is D. If it is sliding downwards, friction must be upwards. So friction force is up the board. So the answer is D. Which statement best describes a couple? Remember, these two forces are equal in magnitude. Their lines of action never meet. They are parallel. So it's a pair of equal magnitude, of forces of equal magnitude acting in opposite directions, which produce a rotational motion but not translational motion. There is no translational motion because the resultant force is 0, but there is a rotation. They cause either clockwise or anti-clockwise movement. So the answer is A. A pair of forces of equal magnitude acting in opposite direction which produce translational. They don't produce translational motion. Translation is to move from one point to another. If there is no resultant force in any direction, then there is no motion from one point to another, but there can be rotation about the same point. So that one is out. So the rest are out. The answer is going to be A. There is no rotational, no, there is no translational motion, but a couple can cause rotation. A uniform rod XY of weight 10 newtons is freely hinged to a wall at X. It is held horizontal by a force F, acting from Y at an angle of 30 degrees to the horizontal as shown in the diagram here. What is the value of F? What is the value of F? Okay, so since it is a uniform rod, its weight is at the midpoint. That's number one. Number two, it is held horizontal, so there is equilibrium. The resultant force, the resultant moment should be 0. So I'll resolve F vertically upwards for easy calculation. And taking F upwards to be F sine of 30. So it will be F sine 30. So I'm going to take moments about point X. this will cause a clockwise moment, the other one will cause anti-clockwise moment. So I'll say F sine of 30 times the perpendicular distance, which I will call, let me just call it distance x to y. It is distance x to y. Then this should be equal to 10 newtons times perpendicular distance. If the other distance is x to y, then this should be a half of x to y. So times a half of x to y. Since it is uniform, its weight acts at the midpoint. So of course x to y, xy cancels out, and I remain with F. So F is going to be equal to 5 divided by sine of 30, which I think this is 10, because it is like 5 divided by 0.5, which is 10 newtons. So the answer is going to be C. Four combinations of vectors are shown. Four combinations of vectors are shown, each representing all the forces acting on an object. The forces all act in the same plane. The object is in equilibrium. The object is in equilibrium. If it is in equilibrium, if there are three, they form a closed triangle. That is obvious. Which combination of vectors could represent the forces acting on the object? So if we check this one, here we don't have a closed triangle. So this means we leave this out. If we check C, we cannot have, if I bring this one here, I cannot form a closed triangle. So it means C is also out. If I bring these ones, if I bring D, when I fix one vector, of course, these are not forming a closed triangle. They are all pointing the same point. Of course, these two are pointing here. There's no way I will combine this. Because of direction, there's no way I will combine. This is joined to this one, but there's no way I'll add this one to form a closed triangle. So this one's out. Then these ones, this is in this direction. On its head, we have added this, so I can prolong this one. So if I bring this one, I consider that one down here, then I have a closed triangle. This is now a closed triangle moving, which is actually clockwise. So that means these are forming what we call a closed triangle. That means they could be acting on a body which is actually in equilibrium. So the answer here is going to be D. A rectangular metal bar exerts a pressure of 15,200 pascals on the horizontal surface on which it rests. The height of the metal bar is 80 centimeters. What is the density of the metal? Okay. The height of the metal bar is 80 centimeters. What is the density of the metal? Okay. So we know that pressure is equal to force over area. The force will be the weight, which will be mg divided by the cross-sectional area. Of course, we know that the mass is density times volume, so this would be density times volume times g over cross-sectional area. Of course, we know that the volume is actually cross-sectional area times another height. So this would be density cross-sectional area times another height times g over a. So this one cancels. So in other words, I'll simply say pressure, which is 15,200 pascals, equals to the density, which is required, times the other length, cross-sectional area times another length, which length is 80 centimeters. So this will be 0.8. Then times g, which is 9.81. So I'll just press my calculator. 15,200 divided by, open brackets, 0.8 times 9.81. So that is 1936 or 1937. So density is 1937 which is approximately 1900, as quoted here, approximately 1900. So the answer is going to be B. A bicycle pedal is connected to a pivot by a metal bar as shown. The force on the pedal is 60 newtons downwards. What is the moment of this force above the pivot? Okay, so I'll just take moments about the pivot. If the force is 60 newtons downwards, its perpendicular distance is going to be 16 centimeters. If the force is 60 newtons downwards, as we see, then its perpendicular distance above the pivot is 16. So taking moments or torque is going to be 60 newtons times the perpendicular distance, which is 16 centimeters, that is 0.16. So this is 60 times 0.16, that is 48 divided by 5, which is 9.6. So this is 9.6 Newton meters. So the answer is going to be B. A thin horizontal beam XY freely hinged at point Y to the vertical wall. The beam is held stationary by a cable XZ, which is attached to the wall at point Z. The beam supports a weight W at point X. The forces in the cable N and the beam are FC and FB, respectively. Which vector triangle represents the forces acting on point X? Of course, if it is in equilibrium, it is horizontal, it is stationary, it is in equilibrium. At point X, we have the weight. We have, of course, there is a force from the hinge which acts in this direction here. And we have the tension here in the cable, tension in that direction. So if I fix the weight vertical downwards, and on the weight I add the horizontal force from the hinge in that direction, then I should add the tension. These three should form a closed triangle if there is equilibrium. So first of all, it should be a closed triangle, which is in that direction. So it should be a closed triangle first of all. It should be either in that direction or the other way around. That is because if I complete this parallelogram here, I could have something like that. So it is either a closed triangle in the other direction or the other direction. If I complete the parallelogram, that is if I was to fix the weight vertically downwards. No, if I was to fix the horizontal force vertically in that direction, then I add the weight, then I add the tension. So it will still be a closed triangle in the other direction. There is no resultant. So that means we need to look for that. So A is a closed triangle which is going like this. So I think the answer is A. Let's check B. B is not a closed triangle. This one goes like that. The other one goes the other way around. This one goes like this. The other one comes the other way around. This is a closed triangle, but this has been reversed in direction, so that is wrong. So our answer is going to be A. A pipe open at one end floats. A pipe open at one end floats as shown. The cross-sectional area of the pipe is 0.012 meters squared. The weight of the pipe is 32 newtons. What is the density of the liquid? What is the density of the liquid? Okay. So to start with, our density is equal to mass over volume. So density will be equal to the mass over the volume. So let's first find the weight of the pipe, of course, according to Archimedes' principle. The weight of the liquid will be equal to the weight of the pipe. That means the mass of the liquid will be equal to the mass of the pipe. So the density of the liquid times the volume of the liquid will be the same as, because mass is density times volume, so this will be the same as the mass of the pipe, and the mass of the pipe is 32 divided by G, which is 9.81. So this will be 32 divided by 9.81. This is according to Archimedes' principle. Okay, so it means the density of the liquid is going to be the 32 divided by 9.81, then divide by volume of the liquid, which is going to be 1 over volume of the liquid. So we have this as 32 divided by 9.81. This was for this one here, for mass, times volume of the liquid, which is going to be the cross-sectional area times the height. So this is going to be the cross-sectional area is 0.012, and of course the height of the liquid which is displaced is 0.3. So that is the volume of the liquid displaced. And I will just press my calculator. 32 divided by open brackets 9.81 times 0.012 times 0.3. That is 906, which is approximately 910. So this is 910 kilograms per meters cubed. So the answer is going to be B. A submarine is in equilibrium in a fully submerged position. What causes the upthrust of the submarine? Of course, we know upthrust is equal to cross-sectional area times difference in pressure. This is cross-sectional area difference in pressure, that is density times G times difference in height. So what causes the upthrust on the submarine? The air in the submarine is less dense than the water. That is not true. There is difference in pressure there is a difference in water pressure acting on the top and on the bottom of the submarine. So the answer is going to be B, difference in pressure on the top and the bottom of the submarine. Two forces, each of magnitude F, act along the edges of the rectangular metal plate as shown. The plate has length A and width B. What is the torque about point P? We want torque about point P. So these are forming a couple. And a couple, the torque of a couple is the product of one of the forces times the perpendicular distance between them. So that is times B. So the answer is automatically B. You don't need to bother about A, whatever. The forces are acting, this acts in this direction, this acts along this, the perpendicular distance between them is B. And the moment of a couple is the product of one of the forces and the perpendicular distance between them. So the answer is F times B. A non-uniform rod has a mass of 100 grams and a length of 50 centimeters. It is supported by a chain at its midpoint. The rod is held in equilibrium by having a mass of 60 grams suspended from its right hand end as shown. The center of gravity of the rod is a distance d from its left end. The center of gravity of the rod is a distance d from its left end. Okay, so the center of gravity is here. That means its weight acts at this point. And if its mass is 100 grams, in kilograms it is 0.1. So this is going to be 0.1 times G, which is 9.81. That is the force, the force due to the rod, or the weight of the rod. What is the value of D? What is the value of D? Okay. Let's take moments about the chain. So this distance here, if it is pivoted at the length is 50 centimeters, it is supported by a chain at its midpoint. So it is at its midpoint. So this distance here is going to be 25 minus D. The other distance is 25. Okay. So let's take moments about the position of the chain. So for the weight, it is 0.1 times 9.81 times the perpendicular distance, which is 25 minus d, should be equal to, so this is going to cause anti-clockwise moment, this will cause clockwise moment, so it should be equal to 60 grams is 0.06, 0.06 times g, which is 9.81 to make it a weight, then times the perpendicular distance, which is 25. I didn't change the units of distance because I know centimeters will cancel out. So checking d, if I make d the subject, so I have 25 minus d is equal to 0.06 divided by 0.1. So I'll just check with the calculator. 0.06 divided by 0.1, that is 0.6. Then I make d the subject, so I'll say 25 minus 0. I'll say 25. Oh, sorry, there is a 25 here. This is times 25. So that is times 25. That is 15. So 25 minus d is equal to 15. So I think d is going to be equal to 10. D is going to be 10, and that is in centimeters. So the answer is going to be A. A light rigid rod XY has an object of weight W fixed at one end. The rod is in equilibrium, resting on a support at Z and a vertical wall at X. The support exerts a force R on the rod as shown. The diagram shows the directions but not the magnitudes of the forces R and W. What is the direction of the force on the rod at X? What is the direction of the force on the rod at X? Okay. So I will try to, because this is in equilibrium, I'm going to try and prolong these forces and see where they meet first. For equilibrium, the moment due to R must be greater than that due to the weight, because the weight causes a clockwise moment and R causes anti-clockwise moment. That is very important for us to note, because if we take moments at X, the moment caused by R should be greater. The torque caused by R should be greater than the torque caused by the weight. Reason: R is closer to this point. Because R is closer, no, R is causing anti-clockwise moment and W is causing clockwise moment. What is the direction of the force on the rod at X? So there should be another force here. So the moment due to R should be greater than the moment due to W, because W causes clockwise moment and R causes anti-clockwise moment. Okay, but since no magnitude, so since there is no magnitude, we cannot rely on we may not easily rely on a closed triangle. Since we're not given any magnitudes here, we may not easily rely on a closed triangle. But let's see, if we prolong these vectors or these forces, where do they meet? And I'll get another force from point X to where these other forces are meeting. So let's prolong this. I'll make the weight vertical downwards. It will go downwards like this. Okay. And I'll prolong this one. These three forces should meet at the same point. Okay. So it means the third point, because I want the force at X to, what is the direction of the force on the rod at X? So I want to find the direction of the force at X. So I'll join X to where these vectors are meeting. So I'll join X to this point here. Is it not working? Okay. So at that point there, so note that this way, this is acting in this direction here. That is acting in that direction there. And this one is acting in this direction here. So it means the force here, so this should be acting in this direction here. So the force here is most likely going to be a force which is acting here. So that if this is W, this is the force at X, then this is R. R should be between these two forces in the opposite direction to balance them. So that means the answer is going to be most likely D, because if R is acting in that direction and the weight is acting in this direction, then if I draw this line from point X meeting at this point, then this should be acting in this direction to balance R. So for equilibrium, the moment due to R must be greater because R is closer to X. So that means X, if the moment due to R is closer, then the force at X should be the other way around, to balance with the moment due to R. So I think the answer is going to be automatically D. Okay. Of course, that is quite technical. I try to draw, you just draw straight lines. Me, I may not be accurate because I'm not using my ruler very well, but this is supposed to be a straight line. It is supposed to be a straight line. Let me try to use my ruler. Okay. So this should, if R is close to point X, then this force here must be acting the other way around, because R is going to be a bigger force since it is closer to X and yet there is balance. R is a bigger force. So to balance R, this should be pointing in that direction. So the answer is automatically D. That is quite technical. It's not something very easy to be seen by anyone. Okay. Liquid Q has twice the density of liquid R. Okay. At depth X in liquid R, the pressure due to the liquid is 4 kilopascals. At which depth in liquid Q is the pressure due to the liquid? 7 kilopascals. Okay. So let the density at R be rho. So the density, because I said liquid Q has twice the density of liquid R, so density of liquid Q is going to be twice rho. That is number one. And we also know that pressure is equal to H rho times G. So for the other one is 4 kilopascals. 4 kilopascals, I'll just say 4 is equal to H. That the depth that is in R, H is X times its density is rho times G. For the second one, pressure is 7, its depth, let it be Y, times the density is twice rho, then times G. I'll just divide the two equations. So I have that 7 divided by 4 is equal to Y into 2 rho times G divided by X times rho G. So G cancels, rho cancels, making Y the subject. Y is equal to 7 over 4 times X. So our answer here is automatically going to be B. So the answer is B. That is fine. Okay. Two people push a vertical gate to open it. The forces exerted by the people on the gate are shown. One person is a distance d1 from the gate's hinge and pushes with the horizontal force F1 at an angle theta1. The other person is at a distance d2 from the hinge and pushes with the horizontal force of F2 at an angle theta2. What is the total moment about the hinge due to the forces F1 and F2. We want total moment. So I'll resolve this vertically upwards. Of course, F1 vertically upwards using this angle here, which is theta. This will be F1 sine of theta 1. And this one here vertically upwards will be F2 sine of theta 2. Okay, so we want total moment. So these two are going to cause, I just resolved them perpendicular so that I get the distances d1 and d2. These two are going to cause moments in the same direction. This is going to cause anticlockwise. This is also going to cause anticlockwise. So total moment is going to be F1 sine of theta 1, that is the force, times perpendicular distance, which is d1, plus F2 sine theta 2, that is the second force, perpendicular distance is d2. So the answer here is automatically going to be B. D1 times F1 sine theta 1 plus D2 times F2 sine theta 2. That is correct. And lastly, for this part 4, lastly, a ball is rolling down a slope at a constant speed. Constant speed. The three forces acting on the ball are its weight, that is vertical downwards. Weight is vertical downwards. Contact normal force, that is at 90 degrees. The contact force normal to the slope, and friction. Friction is going to be vertically upward, up the slope. Okay. Remember, these should form a resultant force 0 because it is moving at a constant speed. Resultant force is equal to 0 because acceleration is 0. So these three forces should form a closed triangle when combined. So if I fix the weight vertically downwards, and on the weight I add the contact normal force in that direction, and I add the friction in that direction, I should form a closed triangle like that, or the other way around. That is, maybe I fix the normal force, and on it I add the weight, which is vertical downwards, and then I add the friction force, which is in that direction. So this is always the weight is always the vertical downwards. So this will also form a closed triangle this side. So it is always a closed triangle. So let's check. First of all, we see which ones form closed triangles. So when I move like this triangle is not closed because this is the other way around. That is wrong. If I move like this is closed. If I move like this is not closed because this is the other way around. If I move like this is closed. So we look at D and B. Now we check the directions. The weight is vertical downwards. That's number one. The normal reaction points in this direction. Okay. Normal reaction is in that direction. So if the weight is perfectly vertical, the normal reaction is that direction. So if I compare these two, I think this is closest. D is closest rather than B. D, although they are both forming closed triangle, D is closest rather than, if you look at this force here, compared with this one here, you notice that they are almost parallel. This is more closer to the horizontal than the other one. When you compare this angle here, you remember you drew a vertical line through that vertically pointing that side. Maybe this is too much. You're supposed to draw a vertical line here, which makes 90 degrees. This is the normal reaction. So if you compare this angle with the horizontal, you notice that this is closest. D is closest compared to this one here. This one is a very small angle, so the answer is going to be D. Okay, so I think that should be the end of part. Let this be the end of part 4. Let this be the end of part 4. We shall begin from page 32 with this particular question here.
I think you have learned something from this video, and as you practice this, you should be picking a lot of content. You should be you should be trying to master the ideas behind resolving, finding resultant of forces, using the word upthrust, use finding resultant force on a body falling in a fluid, and so on and so forth. See you in part 5 of force, density, and pressure. Bye bye.